We are going to cover aggregation. That's kind of this week's content. And I kind of did a little blurb in the announcement about what aggregation is. And aggregation is one of those things that when I was first learning, it never really like clicked what was going on. So I'm going to try my darndest to see if we can make that work. And I'm actually going to try to use this here. So I'm going to use Sequila and see if we can make this work. So aggregation, basically aggregation in its most simple definition is we take many things and aggregate them into one. And I know I use the same word. So basically we summarize in some way, shape, or form many things, basically turn many things into one. And so a good example of aggregation is like a GPA. You have many letter grades, and if we want to know your overall GPA, we aggregate values of your letter grade to create an overall GPA. So that's a good example. And there's lots of different functions that we can do to kind of aggregate our data. And so in the reading, you'll read about some of these functions. And I'm going to cover a couple here. Probably the one that's most popular is sum, which we've all used in Excel worksheets, but let's give a quick example. So let's start off with I always forget the name of the table. I think it's sales payment. Let's try payment. Select everything for payment. All right, so in our payment table, you can see that we have this amount column. And basically, these are customers buying things, or in this case, they're renting movies. So a lot of this, we might want to know, like, there's lots of different use cases, what we might want to do. But in this case, what I want to know is like, okay, which customer is our best spender, or, our biggest spender? So let's just start off with that. So this is over lifetime, because so there's payment dates here. But in this case, we're just going to look for lifetime. So just to start off, I want to do a sum. So let's say, how much is total? How much revenue total have we done? So I'm just going to select the sum of amount from payment. And you'll notice I can run this and I do get a result. It's $67,416. So in the lifetime of all of our data, we've had a total payments equaling $67,416. But if I want to see this by customer, we kind of have to tell the database how we kind of want to see that. So what I'm going to do is add our customer ID here to the table. Now, if I go ahead and run this, you're going to notice that I get an error, and it says in aggregated query without group by, right? And so basically what this is saying is it's saying, hey, look, you need to have a group by statement so I know how to do this, which, when we only have one other column, it kind of makes sense. Like, I want to see the sum by the customer, but computers aren't as smart as humans. They can't infer things, so we just have to tell it. So if we want to see the sum of the amount grouped by the customer, we just have to tell it, I want to group this by the customer ID. Right. And so now we can see all of our customers and how much each one individually has done in total. Now, before we saw multiple customers of one, but now we'll only see one row per customer with the total. So we're taking all of the rows that customer one had, summing them up, and getting a result. Similarly, we can use another function like, what is the average amount? And now we can see, okay, on average, which of our customers spends the most per visit, right? Which is also intriguing. And you know what, just for the sake of being clever, let's actually combine these two because I think both are important. And this is kind of where you get into some of this business intelligence type stuff. So let's say we want to see the as total lifetime, then as average order amount. So now we can see a customer's total lifetime orders as well as their average order amount. And let's order this so we can see it in some ways that make sense. So I'm going to say order by, and then I'm just going to say total lifetime and average order amount. You'll notice that I use the aliases in the order by, and it worked, which is great. Now this is going ascending, so I actually want to see this descending because I want to see our top spenders first, and I want to know what their average order amount is. Okay, so we can see that whoever customer ID 526 is has spent the most money with us, and they have a pretty decent average order amount, which is pretty cool. All right, so now we're going to do something a little bit more. So we're going to kind of build on this. So I'm just going to get some customer information. So I want to get like first name, last name, that kind of stuff. So we're just going to do a quick join to say we want it where the payment customer ID is equal to the customer ID. And instead of getting the, we'll pull the customer ID as well, but we also want some information. So in this case, I'm going to concatenate C dot first name, a space, and C dot last name. His full name, right? So now we want to see, oh, the people's names with their stuff. So we're just not looking at a customer ID. Now I run this, it's going to fail. Oh, actually it's not because we're still grouping by the customer ID. So that worked because the customer and the ID are one-to-one still. There are times that we need to add more items to the group by clause. So I'm trying to think of an example. Let's say, let's try this. So if I add the staff ID to say like, oh, how much has each customer spent at for each staff, or let's actually, instead of staff, let's do store ID. You know, I kind of want to add, apparently we don't have a store ID. Let's oh, because it's attached to the rental. Okay, let's just go with staff ID for right now. So if I add staff ID, I need to also add it to the group by clause. There we go. So now we can see each one of the customers and which staff member they purchased through and for how much. So we can see that a few people have actually purchased through multiple staff members. I'm going to take staff member out for right now, just now that we've demoed that. Okay, you can add multiple columns to the group by, and sometimes you have to. And general rule of thumb is that most of the time, if you just take and copy your whatever comes before your aggregate functions, if you just put the columns that come before that, that usually solves the problem. That's kind of been my rule of thumb, because really we want basically these are our slices is how I like to put it. And we want to see like, oh, the total revenue by, you know, the customer information. If that makes sense. Is everyone with me so far up to that point? Does that make sense to everybody, kind of what we're doing here?
Yes.
Yes.
Perfect.
Yep.
Awesome. All right, and what's cool, so now what I'm actually going to do is take this up another notch, because I think you guys kind of get the basics. There's lots of different functions, like rank, sum, average. I even think there's like, I don't know if there's median. There's lots of different functions that will aggregate things. Count is another one. Like actually, let's just say for the sake of seeing like, oh, the average order amount, let's get the count distinct of p dot rental ID as total rentals. So now we can see, oh, not only the total lifetime, the average order amount, but we can also see the total number of rentals that each person's had. So you can, there's another one. And I use distinct. In this case, rental ID is most likely going to be distinct anyways, but just to be sure I did it. So really, I'm just counting the rentals to see how many total they had. Which is really, we could just count, in this case, we could count a lot of specific things. So like we could just do p dot payment ID and we should have the same result, which in this case we do. Basically just count the distinct rentals. So I like to use a key in this case, that'll work. All right, so I'm gonna take this up one more because most of the time, like that's pretty self-explanatory. Like, okay, I wanna see, you know, the totals of this, that, whatever. But there may come a point where like, what if I wanna know how much someone spent and then what that is as a percentage of the total, right? So what's tricky about this is we already have the sum of amount, but we have to group it by the person. So what we might want to do is get when really what we want to do is get the total sum of all. So we get like kind of like a percentage. So what I'm going to do is, let's say I want the sum of amount, and I'm going to say over. And I need to take this out because we don't have it anymore. And our amount. Ah, yes. Okay. So I added this other one, which is this over. So we just need to add this here, p dot amount. There we go. Right. There's some weirdness going on, as you can see. Like a lot of these people have like the same stuff. So this is basically called window functions. And window functions are kind of like a way to like run a function over a subset of things. So what I'm going to do is I'm actually going to pop this out real quick. Let's just put over right here. Take this out. And technically, I don't know if I even need a group by. So let's just take this out real quick. All right. So what we have here is we actually have all of our total lifetimes, and we're not grouping anything. So we actually see all the data here. So for example, p dot amount. So these are all the dates, all the purchases they've done, but now I have this total lifetime, and this is called a window function. And the reason we call it a window function is you can kind of run a function over a window of the subset of data. In this case, we're running over everything. But what I'm going to do is I'm actually going to have it partitioned by c.customer ID. There we go. So now what I'm seeing is each customer's individual order and their total lifetime. And you'll notice I don't have a group by, and that's because I'm using this window partition. and I'm partitioning it by the customer ID. So what this lets me do is it lets me get the overall. So now let's say I wanted to get a percentage. So let's say the sum of amount. We'll take the sum of amount divided by the sum over. See what we get if we just run this. Okay, yep, we need a group by. We still need a group by for our amount. Or sorry, not the, we want to see what the percentage of the total is. Sorry, I'm thinking about this all wrong here. Out the by. All right, looks like we're still missing something here. We have, oh, and I actually don't even need this. Overcomplicating it. P dot amount. There we go. And just to say that we're doing this properly, we want to times this by 100 to get it in percentage form. So as far as like the overall total, this is our percentage. So like all of Mary Smith's orders and what percentage those are of the total, if that makes sense. So 299 is not a lot of the total, if that makes sense. And anyways, we can use window functions in a lot of different ways. So let's think of another use case. So instead of customer, let's extract the year from what is our payment date. Okay, so now we have our year. Let's take this all out. And I'm going to get the sum of amount as the total. We can get rid of our grouped customer. We'll leave that alone. We're going to group by purchase year. All right, so it looks like we were only in operation 2 years. Let's take this down to the month level and see what we get. Okay. Also, looks like we had a few months where we didn't get orders. Let's leave that just like that. Okay, so now we have the sum of amount. Our group by is here, which is great. I'm missing one of these. Those two, and finally. Not use the Windows sum function in this context. Let's think. Inside, let's just put it on the outside, I think. There we go. Okay. So now this is going to be our monthly with our percent of total. And we'll do this one with the customer one as well. Percent of total. Let's take this whole thing and we'll times it by 1,000. Technically, we don't need the brackets, but or by 100, we're just gonna do it anyways. All right, so now we can see our total sales along with a percentage of the total, which is really cool. So here we can see that, $404,824 is 7% of our total. And if we were to sum all these, it would end up being 100%. I'm going to pause there before we switch that to the customer one. I know this is a little confusing and we kind of jumbled around there for a second, but does this make sense to everybody what we're doing here? And it's 100% okay if the answer is no, or if you just have like a specific question.
I mean, I'm following.
Okay. Yeah, this one's kind of crazy, and I'll just kind of like explain this a little bit because we wanted the total amount, and I guess really let me just parse this out to show like each of these pieces. So I'm going to call this total monthly, and then I'm going to call this one as total. So really what we wanted to do is we wanted to, because we're already grouping these, we can't then group it again unless we built this as a subquery, which is oftentimes a pain. And so that's where these window functions come in. So basically using this over, what I do is I sum the total sum of the amount. So we already have the sum of amount, which is each one of these. So imagine these being in a list, and basically I sum all of those up over the whole table. So basically just getting a total sum, as you can see here. So basically each one of these all have the same value, which is what we wanted, because really all we're doing is we're taking 514 divided by 67,000, and we end up with, and multiply it by 100 to get this percentage. So that's kind of like what the window function does. And we kind of like rolled it up into a nice little business use case, but they can be used for a lot of various things, such as rank. So like, let's say I wanted to rank the sum. So really what I would do is I would say I want to rank the sum of amount over the whole thing. And let's see, what did I do here that's wrong? Does MySQL do a rank function? Let's try it here. Maybe we don't need sum in here. We need, I don't think, oh, we need a order by There we go. That's what I was missing. There we go. Okay. So now what we should have is we should have our best months ranked. So now instead of sorting by the month, I'm going to sort by the best month rank. And now we should see the money go down, which we do. Our best month is ranked number 1, second, and finally down to our worst. So that's kind of another use case. And so when we use our over, we can say, we showed one where we do like a partition by, which is kind of how we slice it. But in this case, when we use the rank function, we need to tell it, oh, how do we want to rank this? In which case we want to rank it by the order of the total sum of amount descending. So again, the sum of amount is a list of these things. And we want to sort that descending, just like what we see here. And then basically the rank function just assigns a number to it. So there's our rank. All right, cool. And I believe that there's one more thing that I'm missing, and I, for the life of me, can't remember it. So I'm gonna real quick, let's go to the reading. Just take a look because I know that I'm missing something. Take a look at some of these min max. Yep, those ones are all good. And maybe this is something when we come back to it. Multi-column grouping.
Did you do roll up yet?
Roll up. That is what I'm missing. Okay. Yep, roll up. Okay, perfect. Thank you for bringing that up. I use so many databases. I got to look up the syntax for this real quick. All right. Yes, perfect. All right. Go back to our real basic one here. Maybe I should use a MySQL workbench for this. Let's try it. All right. So with roll up, let's take a look here. Multi-column grouping, we did that. Generating roll-ups. Okay. So basically, if we have more than one thing here, so let's what do they use? Oh, they use a count by actor rating. It's a good idea. Let's try it in here. Use Skila. Let's kind of mimic there. Select. Film ID. Right. And then we want a count of films. I think film rating is it. Let's rating. Yep. Okay, perfect. We're going to get a count of f.film ID. All right, so we have that. We need to group by a.actor ID, f.rating. And again, this is where I really like my, I don't know, you can format yours however you want, but I like to kind of see mine in list form. So I'm going to go ahead and do this. All right, so there's our count of actors and films by ratings, or our count of films by ratings. There we go. And we're going to do the with roll up option. All right. So basically what the roll up option does is it's going to generate a kind of total line, so to speak. And we can kind of see this here happening. So you'll notice that for actor 1, we have a G, 4 G rated films, 5 NC-17, 6 PG, 1 PG-13, and 3 rated R. And then this null column, the one we're rating is null, that will be that's kind of like our total line. So actor 1 has been in a total of 19 films. So if we were to take and sum all this up, so 4, 10 plus 9, that's 19. So this line is actually our total roll up. So like if we want to say, oh, like, you know, kind of like in segments, like, okay, here's our actor, here's how many, there's the ratings and the count of films, it's going to do kind of like a subtotal. And I guess that's the right word. It will subtotal basically our main slice, or if we have multiple slices, it will do multiple. So that's just kind of a nice little option, is this roll up, because it kind of puts it in like a nice form if you want to have kind of like a subtotal. This is really handy if you're like exporting to like Excel and you kind of like want it there. That it's really nice, that with roll up option. Yes, thank you for bringing that up. I think that's all. I was kind of trying to scroll through here to see if there's anything. Okay, yep, there's one more thing. So that's the roll up. Does anyone have any questions about the roll ups? While we're here, I kind of want to see how that roll up looks in here. Should look the exact same, I'd imagine. Some of these will actually put little carets on there so you can like hide it and just show the total, but it doesn't look like these are doing that. Okay. So there's our subtotal lines. That's the roll up. All right. So the last thing that I want to cover, so we kind of had this little nice little view, and this is our total. This one we have our by year. But I kind of want to go back to our customers, right? So let's go back to our P.customer ID. And instead of grouping by purchase year, I'm going to group by P.customer ID. All right. So we kind of have our same kind of view. This time we're looking at it by customer. We have our customers ranked. But let's say that I only want to see people like, you know, because there's a lot here. You know, the one nice thing we can do is we can limit this. So like if I want to see my top 10, but there are maybe times where we want to filter based on a total. So like in this case, we see our top 10, but let's say I just want to see my, I want to filter this by an aggregation. So in this case, I want to see it where, you know, like we've done where's before, but we've never done with aggregation. So let's say I only want to see this where people have rented, like let's say we want to bucket it, right? Like by the total number of movies that they've rented, like okay, we know that these people have rented a lot of movies to be a high spender, but let's say that we want to see people who have rented less than 10 movies, because we kind of want to see like, oh, like of the people who aren't renting as many movies, how are their behaviors. So if I put like a where clause like we normally would, where the count of P dot payment ID is, let's say, less than or equal to 10. Now, if I were to do this, I'm going to get an error. And that's because we can't use the where clause to filter on aggregation. The where clause will filter results pre-aggregation, but not before. So we have to use this having clause. If we say having a count of P dot payment ID that's less than or equal to 10, then we get that, but we actually don't have any that are less than or equal to 10. That's interesting. So let's try less than or equal to 25. Okay, now we have some. So now we're seeing our top spenders, or we're seeing all of our spenders, but we're seeing it ranked by spend for people who have rented less than 25 movies. Now let's add a little bit to this. So I'm going to say where P dot, let's extract. We're just going to get this for 2005. We're going to extract the year from P dot date is equal to 2005, I believe was the year. All right. So this kind of puts all of the components together. We actually have every clause that we can have in a select statement in this query. So we have obviously our select list, which actually happens last. We have a from clause where we get our data. And in fact, just to really kind of make this a robust thing here, we're gonna bring it all in. And instead of our customer ID, we're gonna do C dot email. Email. All right, so now we have our email addresses of all of our customers instead of something else. That way we can, like, maybe we're looking to send our top people an email, right? And this is only for the year 2005. So, it's Christmas time. It's getting close to the end of the year. And let's say that we kind of have 3 different categories because we kind of want to like hit all of our customers. So we're going to send an email to people who, to our top spenders, but I also want to send an email to people who maybe don't rent as many movies, but are still up there in the top, maybe something like that. So in this case, we could, we have all of our clauses, from with a join. So this is all considered the from clause. And if it helps to make sense of it, I will just tab this in so it's there. So yeah, so I'm going to run through how the select statements actually operate. And I think I've gone through this before, but this was before we knew about aggregation and the group by clause and the having clause and all that kind of stuff. And this SQL statement actually has every clause that we can have. So that's why we're going to go over it. So the first thing that always runs in any select statement is the from clause. We have to know where we're getting our data from. So that's the first thing that happens. And as such, the joins happen as well. That's what makes the new join, like using like an inner join versus the old ANSI 89 syntax, so much better, is because in ANSI 89 syntax, the from clause would multiply everything and then filter it out in the where clause, which means that all that data is sitting in memory in the meantime before we filter it. But in this case, because our join condition is inside the from clause, they've made some magic, and I can't exactly explain how or why because it's proprietary, but it's faster because I'm assuming that it's doing the matching as it loads the data. So that way there's not as much data loaded to begin with. So we get all of our data. We get all the data from payment, all the data from customer, where the customer IDs match. Once we're there, we're going to filter the results additionally. So basically we only want records where the year of payment date is 2005. So that's the second thing that runs. So first the from clause, second the where clause, which makes sense because, you know, we want to filter out our data as quickly as possible. Because if all we care about is 2005, I don't want to hold 10 more years of memory in my RAM while I work with just 2005 data. So we want to get our data and filter it immediately. Then the next thing that runs is our group by clause. And our group by clause is going to basically lump everything together and that sort of thing. So our group by clause runs next, followed by our having clause, because then again, we're going to filter things down again. So it's going to say, okay, aggregate these columns by the email address. And then I want to filter again, because we always want to filter whenever possible down to where the payment is equal to 25. And the reason that we have to have two separate filter clauses is because we have to aggregate after it's been filtered initially. So that's why basically the where clause and the having clause both filter, but the where clause will filter normal column values like we've been doing. And the having clause will do aggregations. So if you need to run a function and filter on that, then yeah, you can use in an aggregate function, then you put that in the having clause. Then we do the order by. And then finally, we do the select statement. And the select statement, all the select statement does is just basically say, oh, what columns do I want to show? And it'll do all the math and all that kind of stuff. Even though like there is some window function stuff going on here that does link in with this group by, really this stuff is last because it just kind of says what to display. So anyways, that's kind of a fun little query because it does have everything there. Actually, it looks like I did something because all these are the same. Oh no, the total, we broke it all down. That makes sense. Okay. Cool. All right. Does anyone have any questions? I don't know if we have any greater than 50. All right. So anyways, that's aggregation. We're at time, I guess. So if anyone has any questions, feel free to stick around. Otherwise, good luck this week. If you have any questions, let me know. You will see some of this stuff in probably not so much of the window functions, like it might like ask you a few questions, but in the exercises, you probably won't see a whole lot of window functions. So don't stress a lot over that. You kind of want to know what they do, maybe play around with one, but you know, you probably won't have to get this crazy with it. So, you know, don't fret about it. It won't be too crazy. But if you have any questions, let me know. Otherwise, have a great week and good luck.
Hey, just wanted to say thanks for doing these recordings and posting them. I've been going back through some of the lessons and